Hi, I am Alper Yazar. Welcome to the fifth part of the video series about my ISO USB RS422 project. In this video, we will see how we can use an ISO USB RS422 board to communicate with another device. In this setup, we have two ISO USB RS422 boards. Suppose that this board demonstrates another device. It can also be another ISO USB RS422 board, or a device communicates with, for example, it may be an RS422 device or two-wire RS485 device or a four-wire RS485 device. And suppose that the distance between these 2 points is 10 meters, and we are going to use these paired cables to connect these two nodes. Length of the cable is 10 meters, and we will use three different configuration files given in firmware folder. This file, this file, or this file. Okay, enjoy the video. Before working with different configurations, let me briefly explain the three different modes, the usage of three different configuration files. And I am in the firmware folder in our project folder. Let's open firmware folder and let's open readme file. Files are explained in here, but let me briefly talk about them. Default configuration is not used for production. We have three different configurations: RS422, RS485, and RS485_SE. So if you use RS422, transmitter and the receiver are always enabled, and this configuration is suitable for multi-point topology, which is RS422 provides, and we can do loopback test. If we use RS485 configuration, it's suitable for both 4-wire and 2-wire topology. The difference is transmitter is enabled when there is a transmission. Otherwise, it is in high impedance state. And it is suitable for multi-drop topology like RS485. And we have a suppressed echo version of RS485. And the difference between these two RS485 configuration is that in this configuration, receiver is disabled when there is a transmission. By doing so, you can suppress echo during transmission. It can occur for two-wire RS485 connection. Obviously, it is impossible to do a loopback test with this configuration. Now, let's suppose that the device that we want to communicate with it has an RS422 interface. Okay, another device is an RS422 device. So, how can we communicate with it? How should we configure our ISO-USB RS422 board, and we should configure with these settings, RS422 settings, of course. So let me do the RS422 connections and show the communication. First, I connect the single pair to show you, and the transmit output of our device is connected through a wire to our RX side of the ISO-USB RS422 board. But to make this connection a full duplex connection, we have to connect the other pair. So let me do it. Now I did the other connection, another pair, and transmit side of the device is connected to receive side to our ISO-USB RS422 board. Now there is a full duplex connection between these two nodes. Let's program our device now. Let's program our converter board as RS422 converter board. I showed to you in previous video, but let me show you again. Okay, we will use FTPROC. I connected my converter board to this virtual machine. So I press scan and parse. Device is found. So we want to apply this configuration file to our device. So right click, apply template from file, and select RS422 configuration file. Click open. OK, and let's program our device. Okay, we are done. We should disconnect and connect the device again to apply these changes. I programmed the board, as you see, unplug and replug the board, and I also plugged the second ISO-USB RS422 board. Remember that it stands for the other device. Cannot see this text now, but it demonstrates the other RS422 device. Unfortunately, I have a problem with my virtual computer. Now I am continuing with my real computer with different serial port terminals. This one shows the this ISO-USB RS422 board, and the rightmost one shows this board. And let's try to send some data. Okay, let's say ISO-USB RS422. We transmit this data, and the other device receive it. Also observe the LEDs transmit and receive, and we try the other direction. Okay, hi ISO-USB RS422. I am another device. Please observe the LEDs. Okay, this is the RS422 configuration. Now in the second case, let's think that we have a 4-wire RS485 a device. Now we want to communicate with it with our ISO USB RS422 converter board. For this configuration, the electrical connection between these two nodes are the same as the connection in the RS422 case. RX pairs goes to TX pairs, and RX pairs on this side goes to TX pairs. Nothing new. For this configuration, if you know that you are the what do I mean by you? The ISO USB RS422 board is the a master board. You may still use this RS422 configuration file. In this case, transmitter of this board is always enabled, but in the single master case, this will not cause any problem. You can use it. But if you have multiple drivers in your network, you should use this configuration file, because by using this configuration file, when this board doesn't transmit anything, transmit drivers goes to high impedance state and leave the bus alone. Actually, it becomes available for other devices, other masters, other transmitters, in other words. So let me program this device using this configuration file. I connected these two devices to my computer. Same setup, same software. Nothing new from the RS422 demonstration. Okay, let me send something from our converter device and reply it from another device. But we are using RS485 protocol now with this configuration file. Lastly, let's suppose that our another device is a 2-wire RS485 device. The main difference between 4-wire RS485 and 2-wire RS485 is that at each node, you can think that at each node there is a local loopback connection, and similarly here. So instead of two pairs between these two nodes, there is a single pair between these two nodes. Okay, in this configuration we can use both this configuration file, which is the programmed configuration now in this device, or similar configuration file with echo suppression. Now let's see the difference between them. Now we have this configuration file, this configuration in this board. Now let's see the differences. I decided to show the difference between these two configuration files at the same time, and I configured this board using this configuration file with echo suppression, and the bottom board, our actual converter board, is configured using this file. So let's see the difference between them. Okay, this is the bottom board, this one. So let's try to send something to other board. So I press keys, but notice that RX and TX LEDs of this board glow at the same time, because there is a loopback connection here, and we are listening what we are transmitting. It's the expected result. Okay, but if we configure our device with this configuration file with echo suppression, and let me clear both windows. Okay, and I will try to transmit a data from this node to this node. Okay. Okay, it should receive something, I think, but it's transmitting. Is there a problem with connection? Okay, I will check it. I checked these loopback cables and changed them. These are cheap Chinese jumpers from eBay, if I remember correctly. And I checked the configurations again. Now let's try it. Okay, now we are on this board. So if we transmit some data, as we saw previously, we are receiving the same data at this node, and the other node receives the data without any problem. Only receive, both transmit and receive. But if we transmit from this node with echo suppression, okay, let me clear the window. Okay, as you can see, there is no echo at the transmitter side, only takes LED close and RX. So the difference between these two configuration file is the echo suppression, as you can see. So that's all for this video. In the next and most probably the last video, I will talk about some problems with this board. The ASUS SPRS 422 board isn't perfect, and I noticed some problems after design and production. So I will talk about them in the next video. See you.